Okay, guys, we're going to go through something you guys already know what you're doing. We're just going to do a little bit more practice, reconfirm it, so we can move on. Tomorrow, we're going to do this thing, and actually we're doing it in AP Chemistry. It's called oxidation process and reduction process in a chemical reaction and what that actually means. Oxidation reduction has to do with movement of electrons from one atom to another atom. And some people can pick it up pretty quick and others get confused because when we say something's adding, they think it becomes a positive charge. But it's electrons being added, and that means you're adding negatives. So actually it becomes a negative charge, or it becomes lesser in charge. So we'll go over that tomorrow. We'll do some examples. With that, some new stuff. And then on Friday we'll do a lab. The lab isn't very lengthy. Probably take you 15, 20 minutes to do, and then we'll talk about the results of the lab. So we're reconfirming some things that we did last would be Monday. Or this last Monday. So the first thing I'd like you to do is to count how many of each element you have, or how many moles of each element you have. And just write that in down below 1A. That's all I want you to do. Count how many you have. Now, you're going to need your periodic table out. If you don't have one, you can look in the back of the text. But everybody has one, and so you can get that out and look at it, because eventually we're going to use that.
I'm confused. Braden was here passing the hallway.
Sometimes he goes to the nurse this period. He's had a long day. So.
Yes, you say you better leave him alone.
This shouldn't take you very long to do.
So, like, you just want us to put the atomic number or whatever?
Nope.
A weight?
Nope. All I want to do is want you to count how many you have of each one.
So, like, just C3.
Yeah, tell me the total of each element in that whole thing.
So, okay, for the O's.
Yeah, combine the O's together.
Okay.
Yep. So we have 4 elements we have to count: copper, carbon, oxygen, and hydrogen. Those are the 4. I need total mole counts for all 4 of those. And just write those all out. You don't have to do anything with the periodic table yet.
Wait, in the one in the middle, would that be cobalt or just 2 separate ones?
Yeah, sometimes students think that's cobalt, and they realize they're both capital. And so you'll never have 2 capitals together that will create an element by itself. So if you had a little O there, then you would say it's cobalt. So, when we take a look at this, we have copper and carbon and oxygen and hydrogen.
I think the only one that I messed up on was probably oxygen.
Well, and sometimes you might put oxygen in 2 spots, but if you realize you have an element in 2 locations, then you can combine them together to make it easier. So, copper we have 3. Carbon we have 2. Oxygen we have 6 here. So there's 6. And then we have 2 here. So that's plus 2. So we have a total of 8, right? And then hydrogen, we have 2. Questions? So you guys were getting pretty good at counting, so I assume that you got those all right. When you're counting them out, next thing I'd like you to do is use those counts, because that's the first step you would do, in which to calculate the molar mass. And we're using the mineral azurite that has copper in it. So what I'm going to have you do is use that data that you came up with, the 3 coppers, and so on, in which to figure the molar mass. So we have copper 3 and carbon 2, oxygen 8, hydrogen 2. So figure out the molar mass. Now, if you don't know how to figure out the molar mass, you have to look up their weights on the periodic table, and it tells you what 1 mole of each one is going to be in the periodic table. So copper is going to be what? 63.546, right? 55 is what I use. Okay? Do that for every one. And when you do that for every one, you're going to add them all up. And you're going to come up with a total. So this is what we call finding a molar mass. So go ahead and calculate the molar mass for that. We just find the total of each one and add them all up. So that's part B. Okay, so I want you to go down to number 2, 2A, and under 2A you're going to use the information you came up with for 1B, and I need you to calculate the percent copper. So I need you to take this information you came up with for 1B, and I need you to find the percent copper for 2A. So go ahead and calculate that out. The mineral we have is called azurite, and its formula is what we have at the top. It's got carbonate and hydroxides associated with the copper. So when it forms the mineral, that's what's in it. And then we're going to have to separate the copper out by getting rid of the carbonate and the hydroxide. And there's methods you can use to get rid of that, and that's processing it. Can't come up with you should not come up with something more than 100%. If you're doing that, because we've had students that will divide and flip them the way they should be divided. So if you come up with over 100% on any of these, you're not going to be right. Because the most you can have is 100%, and that would be a pure sample of it if you had 100%. So what you do is you take the total, and you would take the 190.65 divided by the total times 100. What'd you guys get for percent? 55.3%. So that would have about 55% copper in it. A little over half of its weight is just copper atoms. Okay, so what I've done on B, I, and 2I, all I'm asking you to do on that example is to take the information that you would generate yourself, like when we did 1A, B, and 2A. On I, I've given you a lot of information, so you don't really have to do a whole lot. And then 2I, there's one little bit you have to do with that one in which to get the answer. So go ahead and figure out. I've got 2 minerals that I want to compare azurite to. Those 2 minerals are bornite and malachite. Those are the 2 other minerals that have copper in it. So what I'm going to do is I need to find a percentage of copper in both of those so I can make a comparison between which one has the most. by weight. Okay, so on I, I'm giving you the molar mass, and I'm giving you the weight of copper. Okay, so that one should be really easy to do. On 2I, I'm giving you the molar mass, but I'm not giving you the weight of copper. So go ahead and do those two, and we'll see what you come up with percentages. They're not going to be a whole lot different from the azurite. They're going to be pretty close to the azurite on how to do that.
So we're using the formula next to Brother to find.
You will not have to do anything with this formula.
Okay.
Or this formula. Because what I've done is I've simplified it for you, and I've given you a lot of that information already.
Okay.
So, and I'll probably do that from time to time so that you don't have to do every single problem. You have to do all the different steps. Might, like on a test, give you a word. You have to do all of it, but then I might make it and simplify it to where you just have to, you're given some information that you would have got if you went through all the steps. But I'm going to give you that information.
I gotta do it.
No, they're going to do it.
They'll figure it out. They'll figure it out. We got 2 doors.
Well,
Well, we had a little. We were doing some. For this first one, all you guys took was 267.73 divided by 451.84, right? Times 100. What'd you guys get for percentage? 59%. Sounds right. And then the other one, you had to take it a little bit further, right? So on this one, I copied that one twice. So on this one, what would I have to do to figure out my answer? I'd have to figure out the amount of copper, right? So the amount of copper, I've got 2 of them, so I'm going to take 2 times 63.55. And then that's going to go over the 221. So I'm going to have 127.1, because I have 2 of them, copper, divided by 221.11 times 100. And that gives me what percent? 57?
Yeah, 57.
Okay, so 57%, 57.5%. Okay, so which one gives me the most? The middle one, right? Bornite? Right? So Bornite gives me 59%. This gives me almost that. So there's not much difference. And the first one is 55%. So there's not a whole lot of difference between any of these. So then it might come down to something to where which one do you have more amount of in a sample that you're mining. Okay? So what they'll do, this is what they do. This is the niobium plot over in Elk Valley. I think it's Elk Valley. Down below Tecumseh, they took these drills and drilled far down into the ground, and they took these cores of samples of the soil. And they have these chunks. And in each chunk, they examine that to see what kind of minerals are there, what the percentages are, and those type of things. And if they find an area that's got a lot in a certain depth of a mineral, then they'll go and see how costly it'll be in which to get down to that depth to get that mineral in which to mine it. So last year about this time they were getting everything ready to get that plant started over there. But I'll have to see kind of where they're in the progress of mining niobium. So what I'm going to have you do, the last thing I'm going to have you do, is to do what we just did on those 3 examples where I gave you some information. And I'm going to have you go down and do the last one. And the last one, we're going to compare magnetite to hematite. We're going to find the percent iron in both of those. And then we're also going to look at how abundant they are in the sample. So we have 25% by weight in a sample in one area, that's magnetite, and we have 30% of hematite in another location. And so we're going to see out which one would be better to mine. So go ahead, go through the whole process, and I've given you a simple formula. Fe3O4 and Fe2O3. So it shouldn't take you too long to find the percentages of both of those. Find the percent of both of those, and then you guys come up with your mind which one you think you would rather, you'd have more iron of, because based upon the percent of iron in the original sample and then how much you have overall in the sample rock that you're mining. So go ahead and do that, and that will finish this up. So again, we have like 72% of iron and magnetite, 70% hematite, and then all we're doing is taking the percentages times the overall percent and realize that hematite would be the better sample.